So first things first, we want to draw this as a series circuit. So here's my battery, has a voltage of 5. Here's my series circuit, so it's connected to 1, 2, 3, and then there. So resistor 1 is 2 ohms. Resistor 2 is 5 ohms. Resistor 3 is 10 ohms. Okay, so series circuits are very easy to do as far as the resistance goes. You just add the numbers together. So the resistance for this is just 2 plus 5 plus 10 is 17. So that's the equivalent resistance. Now, in order to figure out what's going on individually, we need to know the equivalent current. And voltage is equal to current times resistance. So the voltage is 5. The current is I that we're solving for. And the resistance is 17 for the whole thing. So the equivalent current be 5 over 17, which let's just 5 over 17. Let's call that 0.29. Okay. So then we need to figure out, prove that Kirchhoff's voltage law is correct. So Kirchhoff's voltage law is this. The sum of all the voltages needs to add up to the battery's voltage. So the battery's voltage is 5. You can also say the sum of the voltages around a loop is 0. Because batteries provide positive voltage and the other things make negative voltage, unless you put them on opposite sides, which is what I'm doing here. So the voltage for resistor 1 plus the voltage for resistor 2 plus the voltage for resistor 3 has to add up to 5. So we need to find each of those individually. And the way we do that is doing V equals IR for each of them. So what we need to do is we need to solve for the voltage. So we're solving for V1, V2, V3. And we need the current and the resistance. The resistance is very easy. It's given for each of these. So the first resistance is 2. And the current is series. So series circuits all have the same current. They all have the same current. So that means the current for all of these is 5/17. Okay, so the voltage for 1 is 10/17. Voltage for 2 would be 25/17. And again, you're more than welcome to turn these into decimals if you want. And V3 would be 50/17. And I know that's all nasty numbers, but let's go ahead and add all the numerators up. So 10 plus 25 plus 50 would be 75. Am I just messing up my math? 85, thank you. Yep, 85/17 gives me 5. So if you add all these up, you get 5 volts. So that proves Kirchhoff's voltage law. Again, I would not do this all as one problem. I wouldn't do this as one problem on the final. It would be multiple problems. It would be like one problem on the current, one problem about the voltage law, something like that. It wouldn't be all one massive thing. Yeah.
46.
Which one?
46.
46.